It is our largest collider in the world. Some people describe it as the world's biggest freezer. It's also the world's biggest.
Imagine a place where scientific boundaries are shattered and where the laws of physics are pushed to their limits. That place is CERN, and today something unimaginable has occurred. It's a phenomenon that challenges everything we thought we knew. What does this phenomenon mean for the future of our universe? The universe is everything, from the tiniest particles to the largest galaxies. Are we prepared, as a human race, to witness this rather unexplainable event? Join us as we embark on a mind-bending journey like no other and uncover this strange event that happened at CERN that no one can explain. Inside a hidden tunnel lies a technological marvel so advanced and extraordinary that it far surpasses any other modern-day technology. Housing this intricate machinery, the tunnel at CERN makes buzzing and humming sounds, almost like a big scientific playground. This is where beams of energy are sent in a big circle. Welcome to the Large Hadron Collider, LHC, at CERN, a place where amazing scientific discoveries happen. The LHC is not an ordinary machine. It's a huge ring that stretches for 17 miles underground, crossing the borders of France and Switzerland. It's designed to make tiny particles go really fast, almost as fast as light. Scientists use the LHC to recreate the conditions that existed right after the Big Bang, a massive explosion that created our universe. When the LHC started working, scientists noticed some strange things happening. The detectors in the collider recorded more particle collisions than expected at certain energy levels. These unexpected events didn't match what scientists had predicted using the standard model of particle physics, which is like the foundation of our understanding of the tiny particles that make up everything in the universe. There were also experiments, called beauty experiments, that aimed to measure the decay of beauty quarks, a type of tiny particle. The results didn't match what the standard model predicted. This suggested that there might be a new kind of physics that we don't know about yet. Neutrinos, which are very elusive particles that hardly interact with anything, also cause confusion. There was an experiment at CERN called the Opera Oscillation Project that tracked neutrinos, and it seemed like they were going faster than light, which goes against what famous scientist Albert Einstein said. Later, it turned out to be a mistake, but it got people excited about the idea of there being extra dimensions. The LHC's experiments also produced heavier Higgs boson particles than expected. This made scientists think that maybe these extra-weight particles were interacting with other particles or fields and dimensions beyond the 3 dimensions we know. Gravity, the force that pulls things downward, remains one of the universe's greatest mysteries. It is the weakest of all the known forces, yet its effects are fundamental. Scientists do not fully understand gravity, and some theories suggest it may spread across multiple dimensions. The Large Hadron Collider, LHC, at CERN has enabled researchers to explore these possibilities. While observations have not conclusively proven the existence of extra dimensions, they challenge existing assumptions about the universe, pushing the boundaries of understanding and opening the door to a new perspective on reality. This is why scientists believe the discoveries made at the LHC could be key to unveiling a new dimension of our universe. At CERN, scientists conduct experiments to study the fundamental building blocks of matter and their interactions. Using the LHC, they recreate conditions similar to those of the early universe by smashing particles together. This method aims to uncover clues about the existence of extra dimensions. Some theories propose that our universe has more than 3 spatial dimensions, but these additional dimensions might be so small and curled up that they remain undetectable with current instruments. However, the powerful collisions at the LHC could briefly reveal these hidden dimensions. If extra dimensions exist, they might bring new particles with them, known as Kaluza-Klein modes. Detecting these particles would leave distinct marks in CERN's detectors and could also influence how known particles behave during collisions. As a child in the San Francisco area, I often visited a Japanese tea garden and observed carp swimming beneath lily pads. The carp's movements seemed to stretch into hidden spaces, much like the way extra dimensions might interact with our visible universe. This interaction could manifest as missing energy or momentum during collisions at the LHC, prompting scientists to consider the possibility of extra dimensions. Additionally, studying particle decay patterns may reveal signs of these dimensions, as interactions with them could alter expected decay behaviors. Although direct proof of extra dimensions remains elusive, the experiments at CERN provide intriguing hints, suggesting that our understanding of the universe might soon expand. Another fascinating area of research at CERN involves quantum entanglement, a phenomenon where particles become interconnected regardless of distance. This connection challenges traditional notions of cause, effect, space, and time. By studying quantum entanglement, scientists aim to push the limits of understanding and explore whether this phenomenon could reveal new insights about space-time and potentially access another dimension. In parallel, scientists are also investigating micro-black holes, theoretical tiny versions of the massive black holes we know. Some theories, such as string theory, suggest that extra dimensions could create micro-black holes at the energy levels produced at CERN. These would be incredibly small and fleeting, disappearing quickly due to Hawking radiation. Observing them would provide strong evidence for extra dimensions, though concerns about safety have been raised. However, scientists believe Hawking radiation would prevent them from becoming dangerous. Studying micro-black holes could offer valuable insights into gravity, space, and time. Their decay and the particles they produce might provide clues about the structure of extra dimensions. These black holes could also leave unique signals in CERN's detectors, signaling interactions between particles and hidden dimensions. While direct evidence for a new dimension remains undiscovered, these experiments push the boundaries of knowledge and could one day reveal the secrets of the universe. CERN scientists also study the Higgs boson, a particle that gives mass to others. The discovery of the Higgs boson was groundbreaking, and its properties could provide indirect evidence for extra dimensions. Some theories propose that interactions with hidden dimensions could influence the Higgs boson's behavior, particularly its mass. Precise measurements of the Higgs boson's properties are compared with theoretical predictions to test these ideas. Moreover, scientists at CERN explore concepts like gravity's rainbow, a theoretical framework combining quantum mechanics and Einstein's general relativity. This theory suggests that extra dimensions might cause gravity to behave differently, creating a rainbow-like spectrum of gravitational effects depending on energy levels. Such effects, if detected, would offer strong evidence for extra dimensions. The search for extra dimensions also intersects with the concept of supersymmetry, a theory proposing partner particles for every known particle. Supersymmetry could explain some mysteries in physics and may connect to the existence of extra dimensions. Although evidence for supersymmetry and extra dimensions remains elusive, researchers continue exploring these ideas, recognizing their potential to reshape our understanding of particle physics and the universe. The journey of scientific exploration brings us closer to unraveling the mysteries that exist beyond our current understanding of the universe. Detecting the effects of energy-dependent gravity would provide strong evidence for the presence of other dimensions. This means that gravity behaves differently based on the amount of energy involved. For example, when particles get very close to extra dimensions, gravity might act in a way that doesn't follow the usual pattern we're used to. Scientists can likewise study how gravity works when particles are at small distances to look for any changes that could indicate the existence of extra dimensions. They can also study black holes, which are objects with extremely strong gravity, to understand if extra dimensions affect them. By comparing their observations to what they expect from theories, scientists can test different ideas and explore the possible existence of other dimensions. But a concept that's even more intriguing is the idea of supersymmetry. It's simply a theory that says there is a partner particle with different properties for every known particle. These partner particles could help explain some mysteries in particle physics. Supersymmetry is also connected to the idea of extra dimensions. It suggests that extra dimensions could help explain why different energy scales like the weak and Planck scales stay stable. It's like an extra dimension balances things out. Scientists are trying to find evidence for supersymmetry and see if it is linked to extra dimensions. However, Scientists have not found any clear evidence for supersymmetry or extra dimensions. It's challenging to prove these ideas experimentally, and it raises questions about the models that rely heavily on them. But researchers are still actively studying supersymmetry because it provides a good framework for understanding particle physics. Like the idea of supersymmetry, scientists at CERN are also actively studying energy and momentum conservation violations. These principles are important in understanding how the universe works.